pass you the slide control?
Yes, please.
Should be there now.
Should we get going?
Why not?
All right. So good afternoon, everyone. This is the Lake Working Group meeting, interim meeting. So my name is Militia, and my co-chair is Steven. Here he is. So I guess we have two note takers already, Giovanni and Christian. So I thank you in advance for taking the notes, guys. This is an IETF meeting, so the note well applies. Please be aware of the IETF policies covering this meeting. So I will get straight to the point. So the agenda for today's meeting is as follows. We will first go through the adopted items, ad hoc traces, and the update on the draft lake odds. And after that, we will go through the individual submission drafts. And I understand some topics of interest to the group that have been proposed. Does anyone want to bash this agenda? I hear none, so I guess we can proceed. And before we go to the first slot, we have a little announcement to make. We are organizing a hackathon in Paris that is not an official IETF hackathon, but it's still relevant to this working group. So we felt it would be interesting for you guys to know about it. So a hackathon will be organized on 21st and 22nd of May 2004 at INRIA Paris premises in Paris. The scope of this hackathon will include some topics of interest to this working group, including ad hoc extensions and applications, but also other related or other works from other IETF working groups such as CORE and ACE. So if you have any questions, please reach out to paris.hackathon@inria.fr. And there is a small website that we are kindly co-hosting at the Lake Working Group GitHub organization. Are there any questions regarding this? I guess most of you already are familiar with that, but just in case you're not, and for the meeting materials, it's useful. All right, I hear no questions. With that, I propose we get started with the first agenda item, and this is the status on ad hoc and the traces document. Joran, will you be taking the lead on this one, or John?
I think Joran was having some audio issues.
Okay. So there is.
And the plan was Göran, but I guess if Göran is unavailable, I can take it. Or we take something else first. I don't know what you want to do. Göran has the slides, and I have not seen the slides, but I can probably present them anyway.
Okay, so let's maybe skip until Göran joins.
Sounds good.
Yeah, let's maybe skip this agenda item and go straight to the Lake odds draft. Steven, are you fine with this?
Sure, yeah.
Okay. So I guess Giovanni can present. He's the slot lead on Lake odds.
Okay, all right. Can you hear me well?
Will I give you the slide control?
Okay.
I'm not seeing how to do it right now.
Sorry.
The button for passing slide control seems to be missing it from my view at the moment. I can give malicious slide control. Maybe you can see how to pass it on to Giovanni.
Yeah, so I'm figuring out how to do that. Giovanni, maybe you can, until I do that, maybe you can just tell me next slide and I will switch on for you.
For sure. All right. So my name is Giovanni Federicheschi, and I'm going to present updates on the draft and the implementation of lightweight authorization on using ad hoc. here is the link to our draft and to our implementation. So next slide, please. The contents include a quick recap of the protocol, some updates on the implementation, and then on the draft, where I will be speaking about adding some opaque information to the messages, error handling, some hints for enrollment that can help with the scalability of the protocols, and also some examples. Next slide, please. So to do a quick recap, so we are talking about lightweight authorization using ad hoc, where we want to leverage the extensions for external authorization data of ad hoc. So we have three main entities: device, which we may be referring to as U, domain authenticator, V, and the enrollment server, W. So the goal is to have the device joining a new network or a new domain. And I'm seeing your time is over. Anyway, so the device will send a voucher request to the domain authenticator. This will be forwarded to the enrollment server. And if allowed, it will receive a voucher response, which will be relayed to the device. On the left, between U and V, we have ad hoc taking place. And okay, next slide, please. But first, some updates on the implementation. So we had a library called ad hoc Rust, which we just renamed it to Lakers. So it's like Lake in Rust. And so it's ad hoc for microcontrollers, but also more. And I will say why more soon. We just released version 0.50, which is now available at Crates.io, which can be added as a regular Rust implementation. And it also includes the recent integrity fix over CR. We also have the lake alts fully implemented. We have U, V, and W that I just mentioned. And we are developing a demo of using the lakeouts. So we want to be following the draft closely with demos and real to help in the development of the draft. And we also have it available in C and in Python, and you can find it on these links. Okay, next slide, please. Now for the draft updates. Next slide. First, I would like to speak about the addition of opaque info in both legs of the communication. So if you remember the figure I showed before, we had U communicating to V and W. So the problem is during discussions, we identified that U and W may need to exchange more information, but this information is maybe not always needed, but it can help in some cases. For example, from U to W, we may want U sending more context about U. For example, which gateways or which authenticators is U detecting right now? From W to U, if it works, maybe W wants to convey a scope of how to interact with this particular gateway that it has just joined. Or if there is an error, then W may want to communicate to you some actionable thing to do about the error. For example, how to maybe to find another gateway that would be suitable for this U. And the solution, it will be for all cases, it will include adding a new field called opaque info of type byte string. And it will be always protected between U and W. So one example of the change for the case 1, which is U sending information to W. So before we had EncID, which is just the ID of the device U encrypted. And now we expand it to enq info. So if we look at the right, we have the plain text of that. And we see that the actual modification is we send not only the identification of U, but also some opaque info that can give more information, more context to W to do the access control decision, or maybe to reply to you in a more actionable way. Okay, next slide, please. And on top of this, when we are deciding this, we also realized that we need more error handling, or at least we need some error handling in the protocol. And in the process, we decided to propose a new ad hoc error called access denied. So we define it in the draft first as a generic error for ad hoc. So if we look here on the right, we have the error code to be defined. Error type will be a specific error content, and the description is access denied. So this content will have a specific reject type, and optionally, it may have a reject information. That the idea is to have some actionable information that the requester may use to try again, for example. And then after defining this error, we go specific and we speak, we write about the lakeout specifically, and we define it as something that can go within reject info that can be used to help to recover from the error. And we are adding opaque info inside of this field. Okay, next slides, please.
Just before we move on, there is a question in chat by Carsten. How does the recipient of the opaque info know what it means?
Okay, so we are still deciding until where we want to set this, because maybe it will be an application defined, or maybe it will be in the protocol. So maybe we need to define what we want it to be on the standard of the protocol, or maybe it will just be application side.
Yeah, typically if we have ways for one protocol to carry things for another protocol, we provide something like a registry. So the various meanings of those things can be registered. So that would be a simple solution here. But yeah, right. You first have to define who actually defines what the meaning of that opaque part actually is. But the word opaque always rings a bell, because if it's opaque, then nobody will know what it means. And you have to have some indication, a registry or something else.
Göran?
Yep. Thanks, Carson. Good question. So for the it's used both in the normal case here and in the error case. For the error case, there is actually an implied registry here with the reject type. So here
right.
For the normal case, that would be part of the protocol defined in the specification. So the error case is sort of more general, and for the other case, it could be part of the either it's left to the application or part of the protocol.
You just said implied registry, which makes another red light light up for me.
No. I mean, what I mean is that we will define this registry.
Good. Yeah, so please think about whether another one would be useful for the opaque data. That's all I'm trying to say.
Do you have a better word for opaque? If the word is giving the wrong association, you can think about that.
Yeah, that's payload, whatever. We can do this offline.
Thanks.
Okay, thank you. Okay, and then one of the content that we think will be useful to be carried in this kind of opaque data is what we are referring to as enrollment hints. So I will describe a problem scenario here. So we have a device U1 trying to enroll via gateway V1, and then it gets denied. Then this same device tries to get to enroll via gateway V2 and keeps getting denied until it finds a certain gateway that will accept it. This can happen if there are many gateways available in the network, and this will cause an consumed time and energy. So it would be good if the protocol could provide a way to accelerate this join. So the proposal is to have you have the ability to tell W which gateways it has discovered, and this can be conveyed as a form of hints sent from you, for example, with SSID or MAC address, within the opaque info, which goes in within EAD1, sent to W. And on the second point, W may tell you which gateways it should use. Of course, this is in the error case. So then W can send the hints about V within the opaque info. Of course, these hints would be optional. It depends if the application, if it makes sense or not. And the goal is to speed up enrollment. And yeah, questions that we have open right now is, should we standardize what kind of identifier should be used here, like MAC address, SSID, PAN ID, or what kind of identifier? And yeah, so that's the main question here.
So we have Christian in the queue. Christian?
Yep. One thing this would depend on, and maybe that's where our understandings of this diverges, that if there's a gateway V and the U tries to enroll with V with the pointer to W, that V that doesn't, for which this won't work, is going to let you talk to do this in the first place. Which would basically allow you to get a communication channel home, even if it's not getting enrolled. A bit like what's it called? Oximan DNS is used to tunnel DNS, even though a client is on a captive portal that would regularly not let it out at all. So for this to work, the gateways would need to allow devices to talk, to proceed with auths to a point where the gateway already knows that this is not a successful operation. So when will the gateway allow that in the first place?
Sorry, in the beginning I didn't fully understand, but you are saying that it implies that V will need to have some more knowledge about you?
No, that V, when V receives this message 1 that has the pointer to the W, and V sees that, hey, this is a W that I don't have any material with them. This will certainly not work. That V will then not forward information at all.
But okay. So the idea is that V, from the point of view of V, it doesn't know nothing about this. So these hints will be encrypted between U and W. So the protocol is the same. So the message is just forward through V, and then W will decide if it will add the hints about V.
But this makes V a gateway to the rest of the internet through a channel that is just a bit inefficient. What V does know something. V does know the pointer. V does know the address of does know the what's it called in the specification, the lock W. And if V says, hey, that's a lock W that I have no pairing with, then my expectation would be that V will not forward, will terminate things already after message 1.
So actually V, it doesn't know if you should join or not. That's why we have W, where in W we will have the access control list, and W will make this decision. So that's why V needs to ask W about it.
Yeah, but it needs to have some information about W that, for example, it has credentials for W.
Yes, so a precondition in the protocol is that V and W are authenticated and they know each other. They trust each other.
So we're starting to run over time, folks.
All right, taking stuff.
Okay, next slide, please. We also added some examples. One is when the flow is authorized using a single gateway, and the second one is when it's denied using multiple gateways. I will skip the details of this one. And finally, so we have the implementation closely following the draft. We have another way for sharing more information about U and W that we identified based on application needs and what we identified that could improve the protocol. We have a new error code that can be used to extend ad hoc. And yeah, I think, yeah, it's good that we hear the input from the working group. Thank you.
Yeah, thank you, Joanna. So do we have any other questions before we skip on to the next presentation? So I guess no. So Göran, the floor is yours.
Thank you. Sorry for being late. So yeah, this is update on ad hoc and traces. Next slide, please. Or maybe I can forward myself. Yeah, thanks. So yeah, I mean, the reason we just wanted to have a heads up on this update that we made a couple of weeks ago, and which was based on a comment by Loic Ferreira on the connection identifier CR, which wasn't included in MAC 2, and that's what this presentation is all about. But we also merged the PR on some clarifications on the use of deterministic CBOR and the check of all zero input for these Edward curve-based Diffie-Hellman. And as a consequence of this changing in MAC 2, we had to update the traces. So what was this change about? As you remember, we had a request to encrypt CR, which we did, and the changes are shown here, before and after, with an arrow in between. So message 2, and before the encryption of CR was in plain text, the red CR, and then we moved it under the encryption, so the blue CR. Another way of saying that is that we changed plaintext 2 to also contain CR. So that was the big change, or the small change we thought, and but we had to do some consequential changes to the transcript hash, because it's not possible to calculate the keys for encrypting if you don't have CR, and if CR is encrypted, then you don't have CR. So therefore, we had to take CR out of the transcript hash for message 2. And since it's included in the plain text with this change, it's included in plain text 2, it's already included in transcript hash 3. So it meant that we previously, before this, we had a dependency on CR in TH2, and after this change, we have a dependency on CR in TH3. So at the end of the day, there will be an integrity protection of CR, but not until you have used TH3. So, and this is a fraction of the key schedule where you see how things go in. So you have TH2 and going in to the expand, and that creates MAC2. And that the consequence of this change was that after we introduced this, CR was not covered by MAC2, so we didn't have integrity verification of CR after message 2. This we thought was, well, I mean, this is not a major issue because connection IDs are the only reason why we have them at all is to facilitate retrieval of protocol state. But it's not a good thing that the application can take actions based on a CR which is not correct or gets the wrong information about CR. So it is desirable to have this integrity already in message 2. And it's actually easy to fix because we can add CR to context 2, which also goes into the same expand function and into MAC2. So that was the change we did. We added CR to context 2. And this was, again, we try to learn lessons about late changes. This encryption of CR came a little bit late in the process, and yeah, you shouldn't make late changes, basically. I think we have fixed the things that we should have fixed, but that's for others to tell. So that's it. We're waiting for the RC editor. It's back in RC editor queue and in waiting for them to come back for the auth 48. Any questions or comments?
Yes, I hear none, so I guess we can skip to the next agenda item. This is Marco who is leading on implementation considerations. Marco.
That's right. Hi, everyone. So this is a status update on this draft on implementation consideration now in version 1. To recap on the motivation, towards the end of the design of EDOC, we realized more and more that a number of aspects very much related to the implementation of EDOC actually were rightly kept out of the specification of the main protocol, but still were useful material to include in a separate document in the interest of implementers of a broader EDOC library of full-fledged applications using EDOC that were going to face the same issues or going to the same thoughts anyway. So the preparation that started and the first version 0 was presented at the IETF meeting November last year, also aligned with the point of the latest working group charter. And what happened since the November meeting? So I posted version 1 of the draft yesterday. I expanded the EDOC word in the title based also on comments in our documents recently, and I mostly adopted feedback I received on version 0 around and after the Prague meeting, especially from John, Joran, and Giovanni. Thank you very much for that. It's a lot of ASCII diagrams added that you can notice, and of course the usual improvements to the editorial presentation. But the main topics are still the same. 3 ones that I'll go through quickly in the next slides. So the handling of EDOC sessions and credentials in case they become invalid, what to do with that. The trust models for learning new authentication credentials of EDOC peers on the fly. So during an EDOC execution, if those credentials are not known in advance. And then the most complicated topic on the side processing that an EDOC peer has to take for the processing of incoming messages, thinking especially of EDOC message queue N3 for the sake of fetching the authentication credential from local storage or not, and the possible processing of EID items, if any is present. So on the first topic, there was really no breaking change here. It's still about considering the 3 separate cases where, as a simple case, the EDOC session becomes invalid, for example, because the credentials involved are not valid anymore. And in that case, we'll purge the session state and rerun EDOC if you want to. As a second case, the application keys derived from an EDOC session, for example, an OSCORE context, have become invalid for some reason. And then if you support the dedicated key update protocol, like kudos for OSCORE, run it. Or, well, if you don't support that, or if it fails, well, you can always rerun EDOC. And then there's a third case, which is very similar to the second one, where the application keys are also bound to access rights, for example, in the form of an ACE access token, and either of the 2 becomes invalid. If the token in particular becomes invalid, that involves also acquiring a new one before running EDOC again. And on this topic, really no breaking changes. It was mostly about clarifying some text, making it a bit simpler to read, and mostly adding the 3 ASCII art diagrams for the 3 different cases I've just mentioned. Okay, on the second topic, this is the one where I've changed the most, taking into account the feedback I got. If a peer is already storing the credX of the other peer used in the EDOC protocol, well, that stored credential is supposed to be still valid and possible to use. But what to do in case an incoming EDOC message specifies by value or by reference a credential of the other peer that is not known yet for the recipient peer. And this used to have 3 possible policies to handle the collection and the processing of credX at the recipient peer. out of the feedback I got. Now it's simpler. It's only two policies at the two extreme of the spectrum, also with simpler names. No learning policy means that it's never good to learn a new credential on the fly. So any credential used in the protocol has to be already stored at message reception time, basically. On the other hand, the learning policy would mean that it's always fine to learn a new credential on the fly, of course, as long as it is successfully validated by the recipient peer. So it's simpler, and well, in the future, we may always revisit this if we want to have more fine-grained policies in this set. Okay, on the third topic, this slide looks exactly like I showed it in Prague. It's the site processing for incoming messages, and this slide refers in particular to the case of message 2 and 3, where you really follow the core ad hoc processing until the decryption of the ciphertext, and then you have basically to divert to a sort of site processing when you take care of the retrieval, validation and processing of credential, possibly assessing if it's okay to learn it on the fly based on the policies I was discussing before. And you may have to process already some EAD items that is fine to process this early already, meaning before the verification of signature or MAC2. And after that, you get back for a short while to the core ad hoc processing to verify signature or MAC-X. And after that, you had to divert again in the interest of processing EID items that had to wait for the message verification to be completed. And finally, you can get back to the core ad hoc processing with all the information available to prepare the next outgoing message. And I've always called so far a side processor object, this environment that has to be, of course, prepared in advance by the application so that the ad hoc core processing can give control at the right point in time and then take it back. On this topic, also thanks to the simplification on the policies for learning new credentials on the fly, I was able to simplify the text, reducing the number of steps, and consistent with that, also introduce new ASCII art diagrams. This is just a selection, especially the one at the extreme right side of the slide is a bit longer in the draft. And the numbers of those steps in the figures are also, of course, aligned with the same number of steps in the text. And that's it. It's all about the same three main topics that I've gone through. And I mentioned already in Prague, I think, a number of additional things that I believe can be useful to have in a document like this, possibly as appendices. One would be additional consideration on the implementation of ad hoc when used, especially with co-op, and co-op blockwise is also used, especially in combination with the ad hoc plus OSCORE combined request defined in the core OSCORE ad hoc document. And most of this content was actually part of an old version of the document, and in core we agreed that it was very much implementation specific and was taken away as more appropriate for implementation considerations documentation. So it might well be a good fit for this document, in fact. But those latest points feel less urgent and complementary, and considering the current status and the feedback received and processed, I believe in the current status, this should be ready to consider for a working group adoption call. Thank you.
Thank you, Marco. So do we have any comments on this draft or questions for Marco? So we had good support in Prague on this draft, so I suppose we could go ahead and lodge the call for adoption on the list. Stephen, do you agree with that way forward?
Sure, yeah.
Okay, so the action item for chairs is to launch the call for adoption for implementation considerations on the list.
Thank you.
So the next item is presented by John. John, you have 10 minutes.
Thank you.
Is that the right slide deck, John? Yeah.
What?
Is that the correct slide?
Yeah, I think so.
Great.
How do I? Can I change, or do I need to tell you to change slide? That's fine.
I think if you're sending video, I lose the ability to pass control for a second. So if you could stop sending video just for 1 second. Okay. And then go again.
Yeah, good. That works. So this is about 2 recent paper that has some implications for ad hoc key update. These are 2 papers. One was accepted and published and presented at Cannes 2023. The other was very recently uploaded to IACRE print. So it will be available in a few days. Very much inspired by discussions in IETF. So the main thing that these papers investigates are symmetric key ratchets. So ratchets are, here is a mechanical ratchet, a couple of hundred years old, Swedish. Nowadays in digital protocols, it means a hash chain of keys where you throw away the old keys. The first paper notices that you can model these ratchets in TLS and Signal as stream ciphers, more explicitly non-additive synchronous stream ciphers. And a stream cipher of a state. In these ratchets, the state is, at least in all the protocols analyzed, the state is a key, traffic key in TLS, PRK out in ad hoc key update. And this means that you can apply a lot of time-main trade-off attacks designed for stream cipher. And what is special with a stream cipher and this key change is basically if you find one key, you find them all. So there is basically it doesn't make sense to talk about single key or multi-key. They're basically the same. You can talk about single connection or multi-connection, makes more sense. This is a second paper, both classifies different kinds of key change and also investigates a lot of security properties for these. This is, at least to my knowledge, not known as at all. Very little is actually known about the security of these. Nonetheless, TLS and Signal has gone all ahead and using these. And this paper classifies 4 different kinds of change. Raw chain is used in TLS, and C chains it's used in MLS. Omega chains are used in Oscar Kudos. Lower here is better. And then we have ad hoc, which lets the application provide a context. So ad hoc supports all or none. It's up to the application. Second paper come to the conclusion that there's a lot of new problems and security attacks on raw and C chains. Raw chains have weak keys, they have repetitive cycles, they have high probability of collision, more than the birthday paradox, and these can be used for attacks. They have predictable shrinking key spaces. And this means that you lose some entropy. So after a while, you don't have enough entropy, the amount of entropy to derive your keys. And then Rosing has some subset property, and you can use these for new time memory trade-off attacks. Here is a summary of the security levels and the requirement on the state, how big keys or state you need. Everything is green is new. generally is that raw chains are quite bad and shouldn't be used at all, should probably be phased out. Xi chains have some problems, but they are useful for out of order messaging, and omega change is the best symmetric. The first paper also analyzes if this kind of symmetric key ratcheting is good at all, and come to the conclusion that frequent use of ephemeral Diffie-Hellman provides much better security. And actually, this security difference is maybe biggest in IoT devices where an attack requires physical presence. The first paper analyzes the DTLS 1.3 procedure to calculate AAD limits. Come to the conclusion that it does not make much sense and should be deprecated. The second paper makes these recommendations stronger. Here are the last slide, and these are the recommendations in the academic paper and text from the academic paper. So these are my recommendation as the author of the paper. My recommendation as the author of ad hoc is that we should not do anything that delays publication at all. And all of these attacks are theoretical improvements. They are, I think, in practice, they are still a little bit out of reach of any practical attacks. So you don't need to be so worried. And they only mostly affect the ad hoc key update. Other recommendations is to provide security levels. Yeah. That's it.
Thank you, John, for sharing this. So my understanding is that we, as ad hoc, we could improve by writing up somewhere the considerations regarding the use of application context in the key update function. And I'm wondering whether, as a working group, we should write up this document and have it in the process.
The question I think the last discussion was that nobody really used key update and everybody wants to use kudos. And I think one suggestion was even to remove the whole key update. Instead, it was moved to an appendix and made optional. So I'm not sure we want to spend time on writing a whole new document. I think we definitely want to provide some security considerations, and I assume we can do that in OAuth 48. But yeah, Göran, did you want to say something?
So first we have Xiang in the queue. I'm not sure if I'm pronouncing correctly the name. I'm sorry.
Okay, I did some work about multi-pass. So I suggest we can did some work about multi-pass tracing. Do you support this?
So I'm not sure what you're referring to as multipass.
Me neither.
Software-defined network. So I suggest we can did some work about software-defined network.
So I think it would be the best to bring this to the mailing list such that we could understand the proposal better. My understanding is that this is not directly related to John's presentations, right? So I propose that you bring this up to the mailing list and then we could discuss it there. Is that okay for you?
You want to base it on time and data. So I think it's also work in software-defined network.
This seems quite unrelated to my presentation, so maybe you can take it
So let's
after.
maybe discuss this in any other business, or if there is any time left at the end of the meeting. Let's say the next person in the queue is Joran.
Yeah. Okay. I think this is what should we do now? How should we react to this this paper? I think if we look at how ad hoc key update is used, I think John already mentioned that there is the appendix. There is an appendix. It's not quoted anywhere in the body of the text. It's only a reference I found is from Kudos, and in Kudos, which is not our problem really, but it's only mentioned as for information because they are not using it. So there is actually an option to just remove this appendix. And another option is that we try to clarify text. There is already options mentioned there how to use ad hoc key update, which are good, if I understand right. I mean, using random numbers or using counters.
Yes.
So I think that we could just build on that and clarify what is, with reference to this new publication, we could say that these are the recommended ways to do it, and or this is the way you should not do it, for example. So I don't think we need to do much here. If we don't, I mean, either we can take away the appendix totally, then we are independent of this, or we could just clarify.
But I guess taking away the appendix would be quite a major change.
If you like. Since we are not using it.
I guess we would have a last call again then. Maybe it's not my call, but I know that some people really want this published, and they don't want to wait 2 more weeks for it to be published.
Right. No. I'm just noting that there is no. Whatever we write in this appendix, there is currently no strong dependence anywhere. So that's why we don't need to take it away. We could just make the security considerations, adapt them to this result. That's fine.
Easiest.
Okay. Steven, did you have a comment?
Yeah, a comment on the question. So I guess as chair, I would rather not see changes to the document. Unless we really need them. The question is, John, can you give a sense of the feasibility of these attacks, and would it make more sense for the IETF to figure out the impact of these attacks on TLS first?
Yeah, probably. I will mail the TLS working group and MLS and Quick core as soon as the paper is published. And it's in preprint now, but I have simulated all the major things in smaller hash chains, so I'm pretty sure they work, but it's still in preprint. I don't think we should do anything drastic. I think some small security consideration in OAuth48 is the way to go.
Right. Okay. So I guess we'll see as we get to the. There was some discussion of this. Was it on CFRG list or some other list? I can't remember.
Yes, that was the first paper. Yeah.
Right. Okay. So I guess just
that was very unrelated to the key update. That was about the procedure in like DTLS to calculate AAD limits, which is kind of related, but also quite independent. So it has nothing to do with ad hoc at all.
Sure. Okay. Generally, I think we should. I mean, I think this sounds like interesting work. I think it might be interesting before we decide what security consideration to add to ad hoc to see what other people think of this in the context of TLS, for example, or Quick or whatever. But I think that would be informative as to what we might be able to say.
If no conclusion, we could just state that I think the first paper is already published and peer-reviewed. We can state that you should. There is additional security considerations for like long chain, lower the security. See these papers would be a very uncontroversial security considerations without even saying exactly how or yeah.
Yeah, or you know, or some text might end up going into Marco's draft or something later on. So that's
yeah.
Okay, great, thanks.
Okay, so we have one more presentation for today, and this is Yushan Song. Yushan, can you hear us?
Yes, yes.
Yeah, so you should have the control over the slides so that you can change them on your own.
Okay, yeah, okay. So hi, my name is Yushan, first year PhD student. So currently,
sorry, Yushan, if I to give you control over the slides, I need to, if you can stop sending video momentarily, and then I can pass the control, and then you can start sending video again. Oh no, hang on, it seems to work now, so you should have control now. So.
Oh yeah, I have it right now.
Great, thank you.
Thank you. Okay, so currently I'm preparing an individual submission of the draft about how to do remote attestation using ad hoc. So that's what I'm gonna present today. And firstly, about the use case for doing remote attestation using ad hoc could be, for example, applied on the low power constraint device. Like the figure on the right, it is a small robotics called Dotbot, and it works on the low power wireless communication. So if it does the remote attestation using, like, for example, TLS, it could require a high memory and energy consumptions. So using ad hoc could be a better choice. And the challenge, like open challenge after it could be doing the remote attestation for a swarm of robotics, as each bot could doing the remote attestation using ad hoc with the gateway, and finally they join the same swarm and operate coordinately together to achieve the task. And right now I will focus on the single peer-to-peer remote attestation, and more specifically, I want to do the remote attestation using ad hoc to verify and confirm the firmware running on the device is currently in the latest firmware version. And in this case, I will do the remote attestation, and typically there are 3 roles for the remote attestation. The attester who is currently in an untrusted state and needs to generate believable information to attest itself and then pass it to the verifier. The verifier can evaluate the evidence and generate the attestation result and pass it finally to the reliant party, who can finally decide what to do with the attester. And right now, another working group called RES has already defined and standardized architecture for doing the remote attestation. And there are 2 different types of the models. The difference between them is that the entity who is responsible to transfer the evidence and attestation result is different. So for the background check model, the reliant party will be responsible for transfer the evidence to the verifier without treating it, and then receive the attestation result from the verifier. And for the passport model, it will be the attester who transfers the evidence to the verifier and finally got the attestation result and pass this attestation result to the reliant party. So my initial focus will be on background check model, which means that the attesters in ad hoc sessions will collocate retro as the attester, and the responder, it will be the gateway who controls finally the access to join the network swarm, and it will collocate retro as the reliant party, and the manufacturer of Dotbots, which is a web server, will outside the ad hoc sessions and acts as a verifier in retro. So about how to do the remote attestation using ad hoc, I think I will use the EAD field, and the figure on the right has more details, which is the initiator will carry the remote attestation proposal in EAD1, and then the reliant party will give it back a remote attestation request in EAD2. And finally, the attester will call an attestation service and generate the evidence and carry this evidence in EAD3 field. And about more details, the message flow will be as the figures here. So firstly, the initiator will send the attestation proposal, which will contain the different types of the evidence that it can generate to the responder. And then the responder will transfer this attestation proposal to the verifier and let verifier to decide which types of the evidence it can support and verify, and then give back the exact type of evidence. And then the initiator will receive like which type of the evidence it should generate and call for an attestation service to generate the evidence and finally carry this evidence in the message 3. And after, it will be verifier evaluates the evidence and give back the attestation resource. So currently, I have created a draft repository about this remote attestation using ad hoc. I completed the introduction and problem description part, and my goal is to publish like this draft before the IETF cutoff. Yeah. Thank you.
Thank you, Yushan. Do we have any questions for Yushan? So there is Michael in the queue.
Do you have any estimates of the size of the additional bytes for the evidence in message 3?
Actually, currently not yet, because I just started to define the general structure of doing the remote attestation. But what I think is that the evidence will be an attestation token, and this attestation token will like bind the identity and some like platform state together as the evidence. But for the exact byte size, I haven't decided yet. I will work on it after.
So do you get freshness from message 2?
Yes, like the verifier will generate the nonce and carry it
you're going to use that
message 2. Yes.
Fantastic.
Okay. Do we have any other questions? I guess not. Thank you, Yushan. So we have 3 minutes. Xiang, do you want to maybe bring up your proposal again? Yeah.
Okay, I'm sorry when the meeting end. I want to discuss some details with the chairman. Okay.
I understand you want to discuss with the chairs.
So Zhang, the tool has the meeting set up for 1 hour and it ends very abruptly. We can see if it's possible to have a chat, but it may be better to do it via email.
Oh, okay. Yeah, I also want to share some work I did before to our group.
Sure. I mean, so I think that the meeting will be abruptly cut off by the tool in a few minutes, but please do send mail to Militia and myself, and we can see how best to proceed from there.
Okay. Thank you. I will send the email to you. Okay.
Great. Thank you.
Great. Thank you. Yaran?
Yep, Militia, maybe you want to say a few words about the hackathon in Paris, just as an announcement.
So I introduced this at the beginning during the chair slide slot. So maybe I can repeat for the
no, not for me, for my sake. I was gone then. So yeah,
yes. So I introduced the hackathon that we are organizing during the chair slides, and again, this will happen on 21st and 22nd of May in Paris, France, hosted by INRIA. And the website you can find on the chair slides, it's parishackathon.lake.wg.org. So yes, I think most of the participants should be aware of it by now. With that, I think it's 16 o'clock Central European time. Thank you everyone for attending the meeting, and we requested a session at IETF-119 in Brisbane. We are still waiting for the slot to be assigned, so we will be meeting and we will take it on from there. Thank you for attending and have a good afternoon.
Great, and thanks to our note takers as well.
Yes, a big million thanks. I forgot to say that. Yes.
Joran, did you have something before we get kicked out, or?
No, I'm fine. Thank you. I'm just wondering what happens to Christian's attempt to continue the discussion here. Well, if they're going to be in this room or somewhere else.
Yeah, I think that it's going to kick us out within a couple of minutes. Is
Okay.
my experience, but they may have changed it. Who knows? You might get more than 2 minutes, or maybe not.
Okay. So Zulip chat looks like where it's going to continue. That's great. Thank you.
All right. Okay, folks. Bye for now. I'll see. I will be in Brisbane, so if those of you who make it there, I'll see you there. I'm not sure if Militia will be or.
No,
or
I'll
not.
be remote. I'll be
Okay.
remote for Brisbane meeting. Yeah.
So.
Yep.
Okay.
All
Thanks
right.
all.
Thank you. Bye.
Thanks. Bye-bye.
So, Militia, do you want to post up the notes, or do you want me to do that? And we have to do an adoption call as well.
Yeah, I can do that. I can do that. I can do a pass, and then I'll post it. Don't worry.
Great. And then, do you want me to do the adoption call for Marco's draft, or do you want to grab
Yeah,
that?
if you could do that, that'd be fine. That'd be great.
Will do.
Yeah.
And
yeah.
so, Jan, go ahead.
When will the next meeting time?
Sure.
What is
We
the
will have a
time for the
session.
next meeting?
We will have a session at the IETF meeting in Brisbane in March.
Every week.
Not every week. No. This group tends to meet typically during IETF meetings, maybe with one interim in between.
Okay, I wanted to send the URL of my draft in the message box. Could you please give me some suggestion about my draft? I wanted to change.
So I'm not sure what draft you mean, Jian. Can you tell me?
Yeah. I send the draft address. Okay, I will send the details in your email.
Yes, that would be great. Thank you, because it's always hard to have all the context in one's head. So that would be much appreciated if you could send an email to Militia and myself, and then we can see where to go from there.
Okay.
Okay, great. Thank you.
Thank you.
So I'm just going to hang on and see at what time they actually cut off the meeting. I think it's in 2 minutes, but maybe they've changed that again. Who knows?
Yeah. Okay, I'm dropping out. Talk to you later.
Cheers.
Bye.
Bye.
really chill about keeping a number of this recently.